Good afternoon and welcome to everyone who is joining us for today's Reactor Stockholm session, which is on stateful patterns in Azure Functions. Today we're welcoming back Massimo Bonanni, who is a Azure technical trainer and has delivered with us previously, so we're delighted to have him back today. Today's session will run over the next 60 minutes and there is the chance to ask questions throughout. So in that Q&A window, you can pop in any questions or comments that you have and we'll get around to them by the end of the session. This session will also be recorded and made available on the Microsoft Reactor YouTube channel. That link will go live towards the end of the week and we will share that with you on the meetup groups. Just a quick note about our code of conduct before we get started today. So it's really just a reminder to everyone to be welcoming and respectful of others. It's a friendly environment that we have here, so feel free to interact with one another, but keeping it welcoming and aware of one another throughout. And with that, I will hand over to Massimo to get us started.
Okay, thanks, Emma. Good afternoon to all of you. Before we start, in the slide, you can see the link for the survey and the number, the event code you can use. Please, it's important for us that you fill the survey. So in the end of the session, please go to this link, use the code and complete the survey. My name is Massimo. I am Azure technical trainer and I try to empower the people to empower the skill of the people in Azure. And today I would like to talk about stateful patterns in Azure Functions. Last month, we talked about the extensibility of the Azure Function, so how you can implement a new trigger, a new binding in the function. Today, we can see an implementation of this extensibility, and in particular, we will see an extension that allows you to create stateful patterns using a technology like Azure Functions that are a stateless technology. So it's important to, in this session, you can understand, of course, how the durable function, the name of the extension, works, and how extend your Azure Function allow you to create a powerful platform in a serverless technology. Okay, first of all, I would like to remind you the code of conduct. So this is our code of conduct. So please read carefully and remember. Then we start. First of all, I want to recap briefly what is an Azure Function. What is an Azure Function? What is the technology behind the Azure Function? So the Azure Function are essentially a snippet of code that allow you to react when something happened in a source. So the first, the start point is an event that happened in the source. I don't know, for example, people write something in a table or a message in a queue or an HTTP call, no matter what. A trigger, the first, the blue arrow you see in the screen is the trigger that run your snippet of code. And your snippet of code is written in different languages like C#, F#, Node.js, Java, PowerShell, and so on. Your piece of code interacts with external services, like, for example, a database or sending a notification and so on. The other arrow you can have, you have one trigger, of course, because only one event type of events wake up your function, run your function. But you can have more than one left side arrow, blue on the end, on the left side, on the right side, sorry. The right side arrow is called binding. You can have more than one bindings. In this session, we will see an implementation of different triggers and different bindings that allow you to implement stateful pattern in the Azure Function. Because it's important, because if you start from the principle and best practices of the Azure Function, you have three important things. First of all, functions must be stateless, because every time you run a function, the that instance is different from the previous one, and it is different from the next one, because you run in a serverless world, so you don't care about where your function run, when your piece of code. So you don't have a state. Your function must be stateless. Second point, function cannot call other functions. Unfortunately, when you have an Azure function, you don't have any binding. The right part, the arrow on the right part that allow you to call another function. So you cannot call. Of course, you can use some pattern like a queue in the middle, but you cannot call directly another function. Then third point, and the function can do only one thing. You need to write the function smallest you can, because your function you pay for the duration of the function and for the occupation of memory. So one of the best practices is your function need to do only one thing, only one small thing. But if you think of a stateful pattern, for example, like a workflow. Now, a workflow have these characteristics. First of all, need to manage the state. Why? Because you need to know every time you run an instance of a workflow, what is the step you are executed before and what is the step you need to execute after. So you need to manage a state. In a workflow, you have an interaction between different components. So probably your flow need to call another component and then wait for the response and then call another one and so on. You need to write some logic over this flow of the interaction, and then the workflow must do more than one thing. Typically, your flow. The workflow is one of example of a stateless, stateful object. So this stateful object need to manage the state, need to call other function, other components, and need to do more than one thing. So it's completely different from the Azure function. So the idea is how I can use Azure functions to write a workflow, to write a stateful component. But the magic is durable functions. The durable function is an extension. What is the durable function? Is an extension of Azure Function. In the way I show you in the last meetup, I suggest you to go to the YouTube and check the video. This extension is based on Azure Functions, of course. Add new trigger and bindings, I show you in a demo, and give you the capability to the extension manage for you the checkpoint and restart. So manage for you the state of the workflow and the restart of the workflow during the next step and so on. When you need to go out and make a new step of the workflow, the extension for you manage the state and the history of your workflow. I show you in a demo. It's based on Durable Task Framework. Durable Task Framework is a long-running persistent workflow in C#, allow you to write long-running persistent workflows in C#. Is used in various teams inside Microsoft. I give you the link. It is open source, of course, and I give you the link of the GitHub repo in the latest slide of this deck. You can find some links. One of these is the GitHub repo for this Durable Task Framework. The idea of Durable Task Framework is the component inside the Azure Function extension called Durable Functions that allow you to store and manage the state. Okay, the state and the history of your workflow and the steps of your workflow. Unfortunately, you can use only C#, F#, and JavaScript. Even the Azure functions are available in different languages. The durable functions are available only in C# and JavaScript. It's a limitation for now. How you can design an Azure durable function? What is the components you have in a durable function? First of all, you have a client. A client is a standard Azure Functions, but so the trigger of this function of the client is one of the standard Azure Function triggers, or your triggers, of course, and is the first step. When you start a workflow, you need to start and the first step, a client. Inside the client, you can use a binding. I show you an interface and an attribute that allow you to start a new instance of your workflow. The workflow is an orchestrator. The orchestrator is the heart of the durable function. Is another function, but use a trigger implemented in the extension, in the durable function extension, and use the durable task framework to store the state step by step every time you need to go ahead and do another step. Generally, the orchestrator orchestrate other functions. The other functions are called activities. The activities are standard Azure functions, as you write normally, but they are started. The trigger that you use in activity are one of the trigger defined in Azure Function components. So every time you need to create a workflow using Azure Function, you need one or more client. You can have one or more client, but only one start your orchestrator. Every workflow instance as an orchestrator, and inside the orchestrator, you interact with different activities. Depends on the workflow, of course. I show you some patterns in this scenario. The first one, the simplest one, probably. We have three functions. I want to call the first one, retrieve the data, and call the second one, the F2, retrieve the data, and call the F3. Okay. You can implement this pattern using a standard Azure Functions, because you can put a queue between F1 and F2 and another queue between F2 and F3. Every time F1 finish the work, write something in a queue, the F2 use the queue trigger to start and manage the data and put the data in the other queue, and so on. What is the limitation of this approach using the queue? First of all, there is no clear relationship between the function and the queue. Yes, you can use a naming convention, whatever you want. Yes, but you need to write a documentation about the queue number 1 is used by F1 to communicate with F2, and so on. Second is an implementation detail. I want that someone for me manage the state. I don't want to implement the queue. If I can, I want that another piece of the Azure function manage the state for me. So I want simply said F1 write pass to F2 a data, F2 pass to F3 the data, and so on. The operation context is difficult, so you need to have something from F1 to F2. You need to pass something from F1 to F2, and you couple, you join, you link F1 with F2, because you have an object, a context you need to pass to every function. And finally, what's happened if something wrong happened, I don't know, in F2. Imagine you call F1, okay, retrieve the data, the result, then call F2, and if something happened in F2, an exception, you need to recall F1 to, I don't know, reverse something, on roll back something. It's difficult because F2 run in another piece of the Azure instead of F1, so it's not easy to manage the error. Every function needs to manage the error, so every function become more complex. Yeah, how I can solve this problem using durable function. This is an example of durable function, and this is an orchestrator. Okay, this is the middleman, the function that manages the orchestration. Remember, you need a client to start this orchestration. Yes, but I show you in the demo. In this piece of code, this snippet of code, you have a trigger. This is one of the triggers you have in durable function. You use an orchestration, you use a context. This is the implementation of the context. The context you need to pass the data from F1 to F2, from F2 to F3, and so on. The context allow you to call different functions. For example, this line here allow you to say, hey, orchestrator, call the F1 and wait for the response. Call F1 and wait for the response in the serverless world, in the serverless language. So what does it mean? The orchestrator stop to works, wait for the F1 run and come back the result. Then the orchestrator start again and go ahead. So remember, this is a standard Azure function. You just use an extension. So remember, an Azure function cannot run forever, for a long time. So every time an orchestrator call another function, the orchestrator will be dehydrated, so the state will be saved, then the orchestrator stop, and when need to restart again, the orchestrator start and go ahead. Remember this part. This is the definition of orchestrator functions. So you can use orchestration trigger to say, hey, runtime, this is an orchestration. This is an orchestrator, so a client can call this one to start an orchestration, and F1, F2, F3 are activity function. I show you in the demo because in the demo I completely implement this scenario. So basically, the first one is the F1. When the F1 finish, return the value in the X variable. I use the X variable to call the F2. When the F2 finish, I retrieve the data in Epsilon, okay, in Epsilon, and then I call the F3 with the data of Epsilon. You can see that in this scenario, I can manage the exception, just manage the error inside the orchestrator. The function F1, F2, and F3 may be simplest, because very simple, because they don't need to manage anything. Just manage the data. Okay, it's simple. The idea is how I can manage the state of the workflow. I say you when the workflow call another function, the workflow wake up, go to the will be removed from the memory and restart again when the function that it called finish. The idea is the platform, the durable function extension use an event sourcing approach to save the state of the workflow. I show you here in this slide. On top, you have the orchestrator function, just for the middle part, the main part of the orchestration function. And in the bottom, you have the three function example, return 42, value +1, value +2. Okay, just a return. When you run the client say to the durable extension, hey, durable extension, I want to start a new orchestrator. And what's happened? The extension use a storage, use a couple of queues, but you don't care about how it uses these queues and so on. Just to understand what is the mechanism, what is the pattern behind the scene. So the client writes something in the storage that managed by durable task framework, and then the orchestrator and then the platform understand that a new orchestrator need to be run. So the orchestrator start and say, okay, you can see this is the event history. Just I simplify the event history. I show you the full event history in the platform, but the task framework, the durable task framework, right? This particular orchestration will be started. Then the orchestrator say, I need to call the F1. Okay, write something in the event history to remember that he called the F1 and wait for the response. Then the platform start the activity and return the result, and write in the event history, hey, F1 completes its job and the return is 42. Then the orchestrator starts again and say, okay, oh, F1, I need to call F1, but F1 is finished. So I go ahead and call F2. F2 will be started and then complete the work, completes the job, and the result is 43. I don't know, just an example. Then the orchestrator start again and say, I need to call F1, but F1 is finished. Okay, I need to call F2, but F2 is finished. So I can jump to the other operation, and then I need to call F3. The mechanism is the same, and then the orchestrator start again. F1 is completed, F2 is completed, F2 is completed, F3 is completed. So the orchestrator is completed. Okay, you have the complete event history that allow you to understand exactly what's happening in each instance of your workflow. I show you in a demo. Go to the, you can find this demo in my repo, GitHub repo. I put the link in the slides and the last slides of the deck. Okay, first of all, this is exactly the code I show you later. Okay. Before this one, I need the client. This is a client. The client, as I said you before, it's a standard Azure function, so you need to have a name for the function. In this scenario, I use an HTTP trigger get. So this piece of code, this snippet of code will be run when I receive an HTTP call, a get HTTP call on the URL localhost /API /functions chaining client. Then I use a binding. This durable client define this argument like using a binding. It is one of the bindings you can find in the extension, in durable function extension. And I start a new orchestrator. I don't pass anything, but you can pass object from the client to the orchestrator. The only limitation is that object must be serializable, because you can understand the platform use a storage and need to serialize the data in the storage, because the client start the orchestration and close. Then the runtime know that need an orchestration to start the orchestration and retrieve the data from the store. So the only limitation for this object, only one object you can pass, but the only limitation is that the object must be serializable. But if you use a plain old CRR object, just a class, you can serialize in JSON without any problem. I show you what this function, this method here, create check status response, give you just when I run the demo. When the client starts a new orchestration, I show you in the previous slide, the platform writes something in a storage and then start the orchestrator. And then every time the orchestrator start, go to the history, understand what's happened before, and then it knows exactly what is the next step you need to do. Let's start and try briefly. In the meantime that the platform starts, I drink the water. I hope there is no update in the Azure Function runtime, but may start immediately. Okay, let me go there. This I show you the website in the second demo. Wait for the startup. Okay, and here we can have this. This is the function. Let me open. Yeah, okay, it's better. This is the link, the URL for the client. So I copy this one. Let me be sure. Okay, I copy this one. I open a browser because it is a simple get, so I can use a browser. I copy this one and run. Okay, I start the client. As you can see, the client start an orchestrator, but he don't wait for the response. Everything is async. So just go ahead. Now start the orchestrator. The client is close its work, close its call. This is the response. So remember, I show you later what kind of interaction you can have between client and orchestrator, but the client call the orchestrator. Don't call the orchestrator, doesn't call the orchestrator. Say to the platform, I want to start an orchestrator and then close. Okay, so remember this approach. I show you what are these links after. Wait for a moment. Then I start the orchestrator. So okay, I call activity F1, and this is F1. When F1 finishes, I start again the orchestrator, and look what's happened. I already call the F1, then jump, because in some place I show you where is the platform right. I call the F1 and the F1 completes. Okay, and go ahead. Let me. Okay, call F2, come back again, start the orchestrator again, the same instance. Okay, the same instance, because every time the orchestrator call another function, the orchestrator will be removed from the memory. Okay, then jump F1, jump F2, then call F3. Okay, and then the orchestrator start again. Let me go F5. The orchestrator starts again, and in this case, jump F1 because it completed its work. Jump F2, jump F3, and return the value. Okay. The question is, the client finish immediately. The orchestrator orchestrate the other function, and first of all, where is the history? Second, how I can retrieve the result? First question, where is the history? I go to the, I'm using a local storage account, but imagine if you are if you are in the cloud, you use of course in the storage. When you open the storage, in the table you can find the two tables: test app history and test app instance. If I go to table test app history, I see exactly the history of my orchestrator. This is exactly the same history I show. I just simplify the history, but you can see you have an ID. This is the ID of the orchestrator. Every time you start a new orchestrator, you have a new ID, a GUID, a GUID. The row key is the step 0, 1, 2, 3, 4, 5, blah, 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 and so on. The timestamp, of course, and for example, orchestrator started, task scheduled, and so on. And every time you have a task scheduled, for example, you have the name of the function F1. And when you have the task completed, for example, this one, you have the result. So even also the function write the result in the state. So every time an orchestrator start can rebuild the state just reading the events he produced. Okay, so this is the magic. And how you can retrieve the state? You have another table called the test app instances. Here you have the for each orchestrator you have a row, and here you have the status. In this case, completed because we complete the state, the orchestrator, and the output. This is the value, the result. In this case, is a number, but you can have a complex object because here you will have the JSON, okay, the serialization. But I don't want to use the storage. I don't want to read in the storage. Then, if I go to the result, you can see I have the status query get URI. And this GUID is the same GUID for the orchestrator. And if I click on that, I have the status, completed the status. So The platform for me exposes some REST API with this form in this signature that allow me to understand the status to terminate a workflow if the workflow is not terminated, or remove the history if I want. Okay, so these endpoints, those endpoints are provided for me directly by the durable task framework. Okay, by the durable task, the durable function extension. But anyway, I can read in the storage. There is no problem. Just a simple. I think I explain in the right way the magic of event sourcing. Okay, just a couple. Sorry. Okay, just a couple of limitation of the orchestrator. The orchestrator cannot write logic that depend on random numbers, current date time, delay, and so on, because every time the orchestrator restarts for a next step, you need to have the same flow. So if you use a random number, the first time have a flow, and then the second one the number changes. So probably it has a different flow. So the platform cannot recreate the state. If you need a random number, you create a function that generates a number and use inside the orchestrator. Second one, you can never do I/O in the orchestrator function. If you need, use a function. The orchestrator call a function. The function do something for you, right in the database and so on. Okay, the orchestrator just orchestrate your workflow. Don't start a new thread because the orchestrator is a function. A function cannot run for a long time. So leave the thread, the multi-thread, leave the concurrency managed by the platform, not you. So you don't need to create a new thread, and don't write infinite loops. Why? Because every time you make a loop, imagine you have a loop, call a function. You call a function, first start the orchestrator, 1 run, then call a function, 2 runs, then restart the orchestrator, 3 runs, then call a function, 4 runs. If you have an infinite loops, you pay a lot, of course, because continue to run function. Every time the orchestrator start again, have 2 runs, one for the orchestrator and the other one for the other function. So it's not a good idea. You don't need to write infinite loops. You need to be sure that your loops ends. Okay. Perfect. And we see the chain. Just to see another pattern more complex than the chain. You need to call F1, retrieve something, and then based on the result, call multiple time another function, F2. Wait for all the function finish and call another function, F3. The first one is called Fanin. The Fanin is simple because the F1 can create a number of objects write in a queue. When the F1 write in a queue, for each object, you start a new F2 function. But FanOut is not simple, because you need to wait for all the functions. You need to wait that all the F2 instances are finished. So it's not good. It's not simple to implement FanOut using a standard Azure function. And you need to track the progress for each F2 because you need to start F3. You need to aggregate the data in this point here, and you need to start the F3. And then you have all the problem in the previous. So remember the queues, the name of the queues, the context, the error. Okay, but in this scenario you also have Fanin, FanOut, and progress. Using durable function, you write something. Is the first time you see something like this, you say, "Oh, it's horrible." But this is the F1. Call activity async F1 and retrieve some result. Imagine an array of int. Then you create a for. Then for each value in the for, you call the F2. You create a task to calling that you will use to call F2. You write in an array, and then tell to the platform, hey platform, I want to start again when all the tasks that I create before are completed. And then in this scenario, in this sample, I make the sum and call the F3. It's not easy to see the first time, but if you know the async await pattern, it's like you write a normal class. You don't care about it is a function or not. But in this approach, with this approach, you can implement this Fanin, FanOut. This is F1. This is the Fanin, the for. This is the Fanin, sorry, the when all. And this is the FanOut, the sum. But you can aggregate the data as you want. Just an example here. And then I call F3. Okay. Another pattern. In this case, in this scenario, I call a function. Then I need to wait for an external event or a timer. And then depends on if I receive an approval event, I go to process approval. Otherwise, if a timer elapsed, I call the escalate function. This is a problem. In this scenario, you have a problem. How you can handle the race condition between an events that arrive from the external world and a timer. You cannot create a timer in a workflow in Orchestrator, because a timer, when you create a timer, it means that you wait for a period of time, but you cannot wait for a period of time in a function. Okay, first of all. Second, you need to implement a mechanism that when you receive an event from the external world, you need to stop the timer. It's not easy. And then all the issues you have in the previous scenario. Using the durable function, you write something like this. You call the activity request approval, then we create a timer. This is a durable timer, so it's managed by the platform. Actually, your orchestrator is not waiting. Your orchestrator will be wake up from the platform when the timer expired, or when you receive an external event. One of the endpoint provided by the platform, the previous endpoints I show you in the demo, is allow you to send an event to an orchestrator. Of course, you need to manage the event inside the orchestrator. An event is just a label, a string, and an object if you want. In this case, the label is approval event. And I don't have, yes, probably I have one object, a Boolean, okay? Then you say to the platform, hey, platform, raise condition between your timeout and an external event, but manage for me, this raise handler. So if the task is the approval event, so I receive an event, then call process approval, close the timeout. I use the cancellation token. The cancellation token is one of the standard approach when you use async await. Okay. Otherwise, call escalate. You can create. You can use whatever you. The number of events you need, because it just you don't need to create an event. Just you need to manage a string and object. So it's up to you. You need 10 events. You can create and manage 10 events, and so on. Okay. And also you can create whatever, how many timeout you want, because every time the timer is managed by the platform. So I want to show you that you use always the context object. When you create a timer, you use the context. When you create a datetime, you use a context. When you say platform, I want to react when arrive an event from the external world, you use a context. So the context is important. It is the value added by the extension. The last one pattern is, imagine you have an object, a function you want to, and you receive more than one data from the outside. You want to save all the data in the function. Just to give you an example, imagine that you have a device in the field, and a device field give a telemetries about the temperature to your platform. You want to aggregate this data in one single function. So the device one will have the function one, the device two will have another instance of the function one, the function two, and so on. For each device, you need an instance that manages the state. Remember then that when you call a function, you call a different instance. So the first data arrive to the function call create a function, an instance. The second one create another one. The third one create another one, and probably you cannot be sure that the events are not the events are managed in the same order using the standard function. And when you save the state, the function cannot manage the state. So you need to use an external database, external storage. Then the correlation from the event, you need to call the same function for the first, the second, the third, and so on, because you need to aggregate the data in an object, in the same object. And even you use a different function, you need to synchronize the state, the access to the state, because you don't want that the order will be changed. Okay, so it's not simple to manage something like this using the standard Azure function. The solution is durable entities. Durable entities is one of the implementation of a durable function, is a particular durable function that allow you to store a state, not a workflow, a state. So you can have an internal state composed by whatever you want, properties that you want. I show you an example in the demo. If you know the actor model is a mathematical model of concurrent computation. Is more or less oldest than I, because it originated in 1973. The idea is an actor can manage only one message at a time, can store an internal state. People cannot manage the state outside, but the external world can send messages to the actor, and the actor can manage the message to change the state, and the actor encapsulate the state. Exactly the same is for the durable entity. Okay. So if you know the actor model, some framework implement this actor model. For example, Orleans is one of that implement the actor model. Service Fabric is another one, a framework that implements actor model. Akka is another framework that implements actor model. Durable entities is similar to actor model. It's not an actor model, but the idea is the same. You have the durable entities or entity function is the same. The name identify the same object. Durable entities or entity functions. Define a set of operation, and you use that operations to manage the state. You cannot manage from outside the state directly, but you can call operation to manage the state. And the platform for you, every time you call a particular function, read the state, change the state, and save the state using the storage. But it's not a problem, your problem. It's just a platform that save and retrieve the state for you. It's a function. I show you. It's a simple function that with a special trigger. Just use a trigger, another trigger, not an orchestration trigger, but a similar one. You can access a function using the name and the key. So you can have, I don't know, My device is the name. My device called device 1. So my device 1 is an entity. My device 2 is another entity, and you can manage in a different way two different states. Okay, status. Every time you can call the operation exposed by the function using the entity key name plus key, the operation name, the name of operation you want to call. You can give an input, of course, and the platform allow you to schedule the call. So you can say to the platform, hey, I don't want to call this operation now. Call for me this operation with this input after, I don't know, 10 minutes. Okay. How you can interact with the entity? You can do three things. First, the first one is the calling, the round trip. So it's two-way communication. You call the entity do something and return a result. The second way, so it's not it's a blocked operation. So you wait for the response, and you wait in the serverless language, in the serverless word. So the call will be removed from the memory, and when the entity return the result, the call will be restart again and go ahead. Okay. Another way is signaling. You can send something to the entities and go ahead. Then the entities will manage the data, exactly as the client do with the orchestrator. When the client call the orchestrator, the client say to the platform, start an orchestrator and close. Exactly the same. It's a fire and forget. And the third is it's a two-way communication. You can say to the platform, I want to retrieve the state. Just retrieve. You cannot change the state, but you can retrieve the state for a particular entity. You cannot do all these operations from all the function, but you can do the first one, the calling, just to the orchestrator. And if you think about how the calling works, it's logically, because an orchestrator call an entity, and the orchestrator will be removed from the memory, where the entity finish the operation, return the data, the orchestrator restart again, exactly as the orchestrator do with the activity, exactly the same. Signaling, you can signal something to an entity in the orchestrator, in a client, okay, and also from another entity. Another entity can signal something to another entity again, okay? The state, a client can retrieve the state. I show you in a demo what is the idea. Anatomy of an entity. An entity is a class, is a standard class with some properties. You can use dependency injection if you want. So it is a standard class. The properties is the state. So every time you call an operation, the platform, if you already had this entity, name and key, retrieve the state and instantiate the class and fill the state with the data the platform has in the storage. A set of operation. Okay, this is this example. You can find this example in my project. Is just a certification profile entity, contain a name, surname, and a list of certification. Just an example. And you can find also the shopping chart in the GitHub repo in the demo. And finally, you have the function. This is the function. As you can see, this is a standard Azure function, because it's marked by a function name attribute, but you use a trigger, entity trigger. When you call the function, the platform call this function here, and then call exactly the operation you're looking for. I show you in the demo briefly, then we finish. Oh, this is the, okay, let me find. This is exactly the same entity I show you in the slides, okay? And you, for example, this one, abstract. this is a standard method. You don't have any particular, you don't have anything it's just a method. You can test this one. I use an object here to communicate with, to receive something from the external world. It's not a problem. And then this is the function that you can use to interact with the entity. For example, to initialize a profile, this is a certification profile. So the first time you create a profile, you need to initialize. I create a client. This is a client, and you can see that it is a client because you have this one, exactly as I showed you when I talk about the client for the orchestrator. And I create an entity ID. As I said, an entity ID is composed by the name of the entity, certification profile entity, and the ID. So imagine you want to create the profile for Massimo Bonanni. You give an ID. So every time you look at Massimo Bonanni, you look at certification profile entity with the ID. ID1 is Massimo, I don't know, ID2 is John, and so on. Then signal entity async. So it means take this object and call this entity ID with that object and call the method called the initialize profile. Let me go, for example, I just want to show get. In this method, exactly the same, it is a client, but I make a query for all the entity in the platform, so I can have the platform for me give me some feature to make queries over the entities. I retrieve all the entities, and then for each of these, I retrieve the states. So if I want to have a list of the data, I can show. Just an example, I give, okay, this is okay. Let me go to no, I need to change something. Wait for a moment. I need to change one thing because otherwise I don't have any data here. Let me write this one and remove this one. Just to give some information to show you. Otherwise, it's empty. It is empty, so you can see anything. In the meantime, I drink something. I remember that you can find this demo in the GitHub repo, so you can play with it without any problem. So if I click on, let me check if the function is started. If I click on profiles, I go to the platform. Let me check if there is a breakpoint here. No, I call this one get profiles here. So retrieve the data from the there is some problem because the function is not started. Wait for a moment. We need to wait for a moment because I will need to wait for the, come on. Okay. I only have two entities inside my storage. And if I go to edit here, I retrieve the data. I don't know, Massimo Bonanni. I save. I come back to the list, and you can see you don't see the data because as I said when a client signal to an entity, the signaling is asynchronous. So here you don't have the data, but in the meantime, the platform updates the entity. So if I update here, probably I have the data. This data here, and I don't know if, and this data, the certification are stored in the storage used by the platform. Is the platform that store the status and retrieve the status for you. So you don't care about the state, just care about the business, the data, the structure of the data, and so on. Okay. Just to show you this one. In the stateful and app instance is the place when the durable entity, durable framework store the data for each entity. As you can see here, let me check where is Massimo. Where is Massimo? This is Massimo. This is the state. Come on. Okay, this is the input is the state, exactly as you can see. I don't know if you see, but let me open this one. There is a JSON name, last name, so exactly the serialization of your property, and each entity is identified by the name and the ID. So the platform uses the same approach you have in the durable function for Orchestrator, but instead of storing the Orchestrator, store the entity. Okay, it's the same. Perfect. Just a couple of things before closing. Remember, all these architecture, all these technologies is intended for reliability, not for latency. Exactly the example I show you. When I change something and the client signal, the client and the entity will not be blocked anyway because you don't have a locked. You cannot have a lock because all the data throw into the storage, and the framework use the data from the storage to start again another entity. But you can wait that the entity finish the data, finish the operation. So it's not for latency, it's intended for reliability, just like the function. Workflow by code, as you can see, you write the code. There is another way in Azure to write a workflow using Logic App. It's completely different. In this scenario, you write a workflow or an entity using code, just code. So pay attention, the code must be write in the right way. You don't have to use object occupy memory because you pay for that. All the requirement I show you in the latest meetup when I talk about the trigger and the binding. Then, if you know the virtual actor, the actor model, or the virtual actor, you can understand what is the durable entity and how the durable entity works. And it solves the concurrency issue using a queue. Basically, every time a client call an orchestrator or a client call an entities, there is a queue between the client and the orchestrator or the entity, and solve the concurrency using the queue. So the queue maintains the order, and you can read the platform read the one message at a time. But it is the right choice. If it is the right choice, so you wait, you are looking for the reliability, but not for latency, it's okay. Otherwise, it's not the right solution for you. Okay, I have 2 minutes. Just check if there is some question. This is my reference, so you can write me whatever you want. You can use the mail or Twitter or LinkedIn. I suggest you also my work about my book about serverless computing. You can find also this part. Let me check if there is some questions. I see in the chat. Come on, Teams. Come on, Teams. Ben, five. Okay. Olive, yes. No Java. The question is, what language is supported for AF, Azure Function? In Azure Function, you have several languages: F#, C#, Node.js, Java, Python, PowerShell, and you have a way to use your language using an handler, custom handler, just for the Azure Function. But for the durable function, you need to use an extension, and that extension allows you to write durable function only in C# and Node.js. So, Andy, I think I can answer to your question. I show you the way you can debug the Azure Function locally. As you can see, I don't use the Azure here. Of course, you can put the function in the Azure, but I show you the way you can test and debug function locally. Alan asks, how does the orchestrator deal with changes to the workflow? Yeah, this is a problem. When you write the code, you write the workflow, and you change something in your code, you need to pay attention, because if you have some entities, some workflows in flight, and the workflow start again, the workflow need to find a compatible code. So if you change something and the workflow don't find exactly the same steps, you receive an error, you receive an exception. So there is a couple, three patterns you can use in the documentation. You can find there are several patterns you can use to avoid a problem like this, but pay attention. If you change the code, you can have some problem with in-flight workflows. Yeah. If in the documentation I put in the last slide, this one, not this one, you can find the pattern to avoid this problem in the flight. I think, Alan, I can answer to your question. Another question. Just to try and understand a bit better, what's happening if a new call to the orchestrator comes while it is conducting on the previous task? Say when F1 is complete but it is not started. A client starts an orchestrator, and the platform for you give a GUID to the orchestrator. If the client starts another, this is a different workflow. So the first one can call the F1 and then waiting for calling F2. The other one can call the F2 and waiting for F3. Okay, just because every time the client starts a new orchestrator, you have a new orchestrator, so you have a new GUID, so it's a different instance. If your client call an existing one, you can call an existing one. For example, if you want to send an event, the event throw into the queue, so the platform maintain the order, the receiving order, because they use the queue to call the orchestrator. Okay. Anonymous, I hope I answered to your question. Yeah, you can find the repo, Anonymous. I don't know if you are the same, but you can find the link in the last slide or now in the video. github.com/ for the demo is github.com/Massimo Bonanni/stateful pattern functions. The first one, Azure Durable Task, is the GitHub repo for the Durable Task framework. I think I answered to all the question. No, there is. Yeah. Thanks, Josh. I don't see the. Thanks also for Python. Yeah. So we extend also for Python. Thank you, Josh. Thank you. So C#, Node.js, and Python, not Java. I think. Okay. Okay. Yeah, it's not an extension using a proxy, but it's the same. Okay. I finish. Thanks to you. Thanks to be here for this 1 hour and some minutes. And if you have some question, you can write a mail. I show you again my reference, and have a good evening. Bye-bye.